Alright, welcome back. In this video, we're going to go over Newman Projection Problems. Now, if you haven't watched my last video on how to draw Newman projections, please watch it, because it doesn't make any sense to watch this video if you don't know how to draw them in the first place. Promise, it's a really good video. It's kind of like driving a car without going to driver's ed and learning how to drive a car, right? You're going to kill someone. In this case, kill your grade. But you won't, because you're watching my video. So, I'm going to tell you something. I'm not an idiot, okay? I know how professors like to write Ochem questions, right? So has this happened to you or maybe a friend? You were in lecture, you understood the content. Then you do the book problems, and then you go to take your test, and you see something like this. Something overly complicated, right? And you're like sitting there, you're like, I don't know what to do, right? I'm so lost. It looks too complicated. We haven't learned this, blah, blah, blah. I'm going to tell you right now that professors love to do this, but as long as you know the basics of Ochem and how to do the problem, you will be completely fine. The professors do this to stress you out, to make you flustered and whatnot. But I promise you, it's the same exact thing. It's just more stuff connected to the molecule. Doesn't matter, everything's still the same. And I'll prove it to you. So let's do letter A. Oh, by the way, I put this little cheat sheet here. This is from the last video, but as a little refresher, what I'm saying here is this diagram is if the perspective is going from left to right, wedges will always be on the right-hand side of the Newman projection, and dashes will be on the left-hand side. If the perspective is going from right to left, dashes will be on the right-hand side, and wedges will be on the left-hand side of the Newman projection. By the way, if you remember this, you'll be completely fine for any Newman questions on your tests. I guarantee it. Let's do letter A. Okay, so the perspective is going from left to right, right? How we know this is because the eye is on the left-hand side, and the arrows point from left-hand side to right-hand side. That's not supposed to be. That's supposed to be an arrow, right? This is the right-hand side, this is the left-hand side. The arrow is going from left to right. So now what we do is draw an invisible laser from the arrow, hitting the molecule. It's supposed to be straight, sorry. Right, it's supposed to be straight, but it hits this carbon first, and then hits this carbon second. This means that this is the front carbon, and this is the back carbon. So now we need to identify the groups attached to the front carbon. So let's do that. So here, I'm going to draw it in purple. So here we have a methyl group. Here we also have a methyl group. And here we also have a methyl group. Perfect. This does not matter because this right here is connected to the back carbon. So we don't care about that for right now. So we have identified the groups, the three groups attached to the front carbon. Now we need to identify which one of these three are pointing directly up or directly down. And the way you do this, the trick to do this, is look at the branch, the bond, / compound atom, going furthest away from the rest of the molecule. You'll notice that this one is going furthest away from the rest of the junk here. Right here is pretty close to that, but this one's going furthest away from the rest of the molecule, right? From the rest of this molecule, this one's going furthest away. Okay? This is the first trick. Now what we need to do is look at the carbon that's in question, which is the front carbon. That's what we're dealing with right now. And simply draw a line to that atom, and you notice it's a downhill slope, right? It's downhill slope. If it's a downhill slope, the compound, or not compound, but the atom is pointing down. This molecule right here is pointing down if it's a downhill slope. Now you're probably wondering to yourself, the common question is, isn't this going up? Because don't you see it's like going up, right? Yes, it looks like an uphill, but you gotta think about this. You look at it from the carbon itself. If you were to draw a line from the carbon to the molecule, it's a downward slope. This means it's pointing down. Okay? So let's draw that. So how do we draw this? First, we need to draw the carbon, the front carbon. And how you do this is by drawing simply a dot. This dot signifies the front carbon right here. Now we need to draw the methyl group going down, which is this right here. So let's do that. It's kind of crooked. Okay, good enough. So let's draw that in. Boom, there we go. Let me make it neater. Okay, now here's another trick. If this group is going down, that means the other two positions must be up. Okay, no matter what it is, it must be up. So always look like this. Okay? Now just say, pretend if the methyl group was pointing up. Let's just pretend, okay? So this would be the front carbon, and the methyl group is pointing up. This means no matter what, by default, the other groups are pointing down. Okay, like this, pointing downwards. This is the front carbon, right? This is going upwards. The other ones are pointing down and at an angle, okay? But in this circumstance, it is not, because this one, like I said, is pointing downwards, right? We're pointing down. Now, since these are the same molecule, both are methyl groups, you just gotta fill it in, right? With that arc, like I said. It's kind of crooked, sorry. There you go, okay? And just fill in the methyl group. Ta-da! Actually, this should be this region, I guess. Doesn't matter. Okay, like that. There we go. Okay? Now, oh, I should say, it wouldn't matter if it was a left or right, if it was a different model, if it was a different molecule. Okay? So say if it was a chlorine, for example, then it would matter. But since they're the same methyl group, they're the same thing, it does not matter, right? You're gonna get the problem right anyway. Now let's look at the back carbon right here. All right, this bad boy right here. So how we depict the back carbon is by drawing a circle. That's an oval. A circle, good enough. This circle depicts the back carbon. Now we need to identify the groups attached to the back carbon. So we have a methyl group right here. And then we have two invisible hydrogens attached to it because carbon must always have 4 bonds, right? So we have a bond here, a bond right here going to the front carbon, but we don't care about that. So that means the other ones are hydrogens. One will be on a dash, one will be on a wedge, and one will be on a dash. Okay? And since they're the same atom, they're both hydrogens, it does not matter which one's on the left or the right. Okay? So let's draw in the methyl group. So I mentioned it's pointing up. So let's draw it pointing up. That's the wrong color. Pointing up. So a simple little line like that, and you draw the methyl group. Since this one's pointing up, the other two groups must be pointing down at an angle. So it's the same thing as the front carbon, right? If the methyl group was pointing down, then the other two groups are pointing up, or vice versa. If the methyl group or the other group is pointing up, the other two ones are pointing down. So this one must be pointing down, and this one's pointing down, and it's a hydrogen. Okay, that's the first one. Let's do letter B. The perspective is going from left to right. Okay? Because the arrow, right, starts from the left-hand side and we're pointing to the right. The invisible laser hits this carbon first and then hits this carbon second. This means that this carbon right here is the front carbon and this right here is the back carbon. Let's draw it. So this would be right here depicting the front carbon. Now from the front carbon, you can clearly see that this one's going furthest away from the rest of the molecule. So this must be either pointing down or up. From the carbon itself, we draw a line going to that molecule, right, which is a methyl group, and it's a downward slope. So this means it's pointing down. So let's draw that. There we go. We have an invisible hydrogen here. So let me draw that in here. There we go. Now, we have a chlorine right here on a wedge. So let's look at our little cheat diagram that I drew here. Since the perspective is going from left to right, the arrow is pointing to the right, right? The arrow right here is pointing to the right. Wedges will always be on the right-hand side of the molecule. Sweet. So, since we have the chlorine here, and it's on a wedge, right? This is a wedge. It must be on the right-hand side of the molecule. So, let's draw. Wrong color. Going to the right-hand side here. There's the chlorine. Since the hydrogen is on a dash, and according to our little diagram here, dashes are on the left-hand side when this perspective is going from left to right. So this hydrogen is forced to go here. Boom. There we go. Now let's do the back carbon. The back carbon is right here. We have a methyl group. So let me draw right in the methyl group here. And then we have a hydrogen here. Same thing, right? We have a dashed chlorine and a wedge on a hydrogen. Hydrogen's on the wedge and the chlorine's on the dash. Using the same rules here. Perspective, since it's going from left to right. Wedge is on the right, dash is on the left. So the chlorine will be on the left-hand side. So first, let's draw in our back carbon here. The circle. The circle is depicting the carbon. Once again, I did not mean for the ruler to come up. Okay, there we go. The chlorine is on a dash, so it's going to be on the left-hand side once again. So let's draw that in. It's on the left-hand side of the molecule, and I drew it in. The methyl group is going straight up, right? From the carbon, it's an upward slope to that molecule. Since it's the upward slope, it's pointing directly up. So let me draw that in. Okay. The hydrogen is on the wedge. And the only remaining spot is here. So let's draw that in. Now, here is another trick. If you see a wedge or a dash, it can never, ever, ever, ever be straight up or in the down position. It's always at an angle here. See, these are angled, right, from the center carbon. If it's a wedge or dash, it's always, always angled, no matter what. So that is your other trick. If you can't tell which one to look at, right? If, for example, here, which one do I know to look at? Well, since this is a dash and this is a wedge, since this is a wedge and this is a dash, it must be at an angle. So that must mean that this one right here must be in the up position or the down position. And right here, obviously, it's in the up position. So let's do letter B. C, sorry. Here, the perspective is going from left to right. Now, notice I drew it on the bottom here. It does not matter. It's supposed to be a trick. I'm trying to trick you. But it does not matter. And I'm still going from the left-hand side to the right-hand side. We're starting the arrow starting from the left-hand side and we're pointing to the right. The invisible laser, the arrow goes through here, the first carbon and the second carbon here, making this the front carbon and this is the back carbon. So let's draw that in by a dot. This is signifying the front carbon. This is the front carbon. Now let's identify the groups that we have. We have a methyl group here. And then we have a hydrogen here. So let's draw that in. The methyl group from the carbon, right, it's an uphill, right, uphill slope, right? We're drawing this from here, the carbon, uphill. This is pointing up. The methyl group is pointing up, so we'll draw that in. Perfect. Now, according to our little diagram here, the perspective is going from left to right. So that means wedges are on the right-hand side and dashes are on the left. So the chlorine is on a wedge. This must mean it's pointing to the right-hand side on the Newman projection. So all we have to do, draw a line to the right-hand side at the chlorine. It's pretty, actually that's pretty big. Hold on. The hydrogen's on the dash, so The only other position is here on the left-hand side. We'll add this up. All right, now the back carbon right here. We have a methyl group, and then we have a hidden hydrogen right here. So let's draw that in. So to depict the center carbon right here, we draw a circle. The methyl group is pointing down, right? From here, we draw a line to the molecule, and it's going straight down. Not straight down, but it's a downward slope. So it's pointing down. We draw a thing right there, pointing down. According to the perspective, we're going from left to right. Wedges are on the right, dashes are on the left. The chlorine is on a wedge, so it is on the right-hand side of the molecule. So, right here. And this would leave the hydrogen right here on the left-hand side. Now, let's do this one. The perspective is now reversed. We are going from the right-hand side to the left. The arrow is pointing to the left, from right to left. So the invisible laser hits this carbon first and this carbon second. This means that this carbon is the front carbon and this is the back carbon because this is hit first. Let's identify the groups. We have a methyl group right here. And then we have an invisible hydrogen lurking right here. Okay. Let's draw in our front carbon by a dot. From the carbon, we are going downwards in a downhill slope here to the methyl group. This means that it's pointing down. And since we have dashes and wedges here, we're going to look at this perspective now, this diagram right here, from right to left. Dashes on the right, wedges will be on the left in this perspective because we are looking from right to left. Right to left. The dash, so I should say, let's do the dash. The dash, the chlorine, right, will be on the right-hand side here. So let's try that in. The hydrogen will be on the remaining position right here. Now let's identify this. This is the second carbon. Let's identify the groups. So the groups we have are the methyl group here, and then a hidden hydrogen here. Okay? So, from the carbon, we go at an uphill slope to get to the methyl group. So it is up, in the up position. So first, I draw in the carbon. It is in the up position. What am I drawing? CH3. Okay. The bromine is on a wedge, and we're looking at this diagram right here, from right to left. Bromine is on a wedge, so it's going to be on the left-hand side of the molecule. On the left-hand side here. And this would let the hydrogen be here. Perfect. Now, let's do the challenge problem now. Now, this looks complicated, but I promise you, it's the exact same thing. It literally is the exact same thing. The perspective is going from left to right. The invisible laser hits this carbon first and hits this carbon second. So this is the front carbon and this is the back carbon right here. So let's draw that in. Now let's identify the groups attached to the first carbon, the front carbon. We have a methyl group right here. And then we have two hydrogens. We have here and then here. Okay? Well, since from this carbon we go straight down at a downhill slope, the methyl group is pointing down. And since we both have hydrogens, it does not matter which one's on the left or the right. So, let's draw that in. Sweet. Now, let's identify the back carbon here. Okay, so let's draw that in with a circle to identify that this resembles the back carbon, which is right here. And so, what groups do we have? Well, we have this huge thing right here and a huge thing right here. So, first let's see from here. We have one group going here, a group going here, right here, and then a hydrogen would be right here. So let me draw that in. Actually, it would be right here. Okay. Oh, I forgot to draw the methyl group. Sorry. Methyl group. Okay, the back carbon. Sorry. Okay. So first we have to identify which one's pointing up and what's pointing down. So, or if it's pointing up or pointing down. So, since we have a dash here and a wedge here and a dash here, this would mean that this is the one that's pointing up or down. Well, since from this carbon we're going at an uphill slope, it's pointing up. So what we're going to do is all we have to do is draw that little bar thing and draw in the rest of the molecule. So we have this. There we go. Just copy and paste this. Okay, that's it. Now the wedge or the dash. Which one's on the left and which one's on the right? Well, let's go back to our cheat sheet. We're looking at this perspective. Wedges are on the right-hand side, dashes are on the left. So this wedge will be on the right-hand side and this hydrogen will be on the left. So let's do the hydrogen first. There we go. Now, this wedge, all we have to do is draw in the little line here to signify it's coming out of the molecule, out of the carbon. And all you have to do is just draw in the rest of the molecule. This tert-butyl group, by the way. It's called a tert-butyl group. It looks like a tree. And there you go. That's it. That's the answer. Isn't it pretty straightforward? Like, this complicated looking molecule compared to this, right? This is more complicated. But it's the same thing. It's the exact same thing. So professors will do this to trick you. Okay, but you know what? Let's do this. Just to prove it to you. I want to do, let's do this. Let me change this to, let's do this. Let me change it to a stupid looking molecule like this, like this, like this, like this, a nitrogen, like this, and then, yeah, that's good enough, okay? So all we have to do is just literally just replace this, right? Copy and paste. So copy and paste. There, that'd be the correct answer for that. See what I mean? It's the same thing, right? That's what I mean. So if you found this video helpful, please like and subscribe. Until next time, later.